Welcome to chapter number 10. On chapter number 10, we're going to be talking about chemical bonding. So, at this point, all the things that we have learned so far, we're going to start combining those and seeing how the elements actually come together to make the compounds. So, to do that, on this chapter, we're going to talk about a new concept, which is the Lewis structures, which you are going to love because this is so easy. And then once we learn what the Lewis structures are, we're gonna learn how to do those for ionic compounds. Because the whole idea of this is we're gonna see how the compounds form so that we can start predicting their properties on the next chapter. And we're also gonna be predicting a chemical formula for an ionic compound based on the Lewis structures. And then we're gonna move into the covalent compounds using Lewis structures. And once we learn how to build Lewis structures, we're gonna see what resonance structures are, which are nothing more than different Lewis structures for the same compound. Once we do that, we're gonna use the power that that's going to give us to determine the actual 3D shape of the molecules, which we're gonna see in future chapters, how that determines properties such as boiling point, melting point, and a lot of other interesting stuff that you saw on the video that I posted for water on the discussion for this week, which is going to be related to determine if a molecule is polar or not, which is going to allow you to understand a lot of the stuff that happens around you on a daily basis. So, super interesting chapter. So, let's start with the first objective. How do we write Lewis structures? And for that, we're going to refer back to what we just learned about the electron configurations. And we're going to start by doing the electron configuration of each one of these elements. So let's begin with nitrogen. Nitrogen in the periodic table is going to be located there, which means my electron configuration, I'm going to go back to the closer noble gas going back. So electron configuration for nitrogen is going to be not neon, helium. Helium, then we go to period number 2, 2s2. We go to the P block, 2p3, and that would be nitrogen. Now let's go ahead and do carbon. So carbon is going to be once more helium, 2s2, 2p2. Chlorine is going to be neon is the closer noble gas going back. Neon, 3s2, 3p5, and argon is gonna be neon is the closest noble gas going back. 3s2, 3p6. So those are the electron configuration for all of that. And if we're going to be doing the Lewis structure, all we care for is the valence electrons. So for nitrogen, we're going to have a total of 5 valence electrons. So what we do with the Lewis structure is going to be, we put the symbol on the center. You can imagine there's 4 sections. So you're going to have a section here, a section there, and a section there. And this is representing the orbitals, and we learn that in any orbital, the maximum of electrons you can put is 2 electrons. And we also learn that if you have 3 orbitals, you do not do this, remember, the Hund's rule. If you have 3 orbitals with the same energy, you put the electrons separate first, and then once you run out of space, that's when you put them together using the Pauli's principle with different spins. So we're going to transfer all that knowledge into the Lewis structure. So we're going to have 4 orbitals, like I already said. So this will be an orbital, this will be another orbital, this will be another orbital, this will be another orbital, and those orbitals represent the S and the Px, Py, and Pz. So if we were on period 2, that would be 2s and 2p6. And that's why you have 1, 2, 3, 4 areas. And each one takes a maximum of 2 electrons, and you don't put 2 electrons together until you are full. So let's do that. So once more, we're going to do nitrogen. Nitrogen have 5 valence electrons, so 1, another one on another orbital, another one on another orbital, and another one on another orbital, and then you have to put one more there. So why is this important? Because this is a model that allows to take everything we learn on the quantum theory and put it on a very simple way. And look at everything we can see from there now. On this Lewis structure, we have 3 valence electrons that are unpaired. That means that nitrogen can make 3 bonds. If you remember, ammonia is NH3 because nitrogen can only make 3 bonds. Hydrogen have only 1 valence electron, so one hydrogen will attach there, completing that. Another hydrogen will attach there, completing that. So we're filling up the orbitals by bringing another element, and that's how we make compounds. But we're going to talk about that later. So for right now, all you have to do is state the symbol, count how many valence electrons you have, and distribute them on those 4 places, and do not put 2 of them together if you still can put any of them by themselves. In very rare instances on future recordings, we're going to see that sometimes you put them together, but in general, keep them separate until you run out of space. So that would be nitrogen. So let's put it to the side. So nitrogen will be like that. Now let's do carbon. Carbon is going to have 4 valence electrons. So carbon will be 1, 2, 3, and 4. Chlorine will have 7 valence electrons. So that would be 1, 2, 3, 4. I run out of space now, so now I have to put them together. And if this was an orbital diagram, they would have one pointing up, one pointing down. With the dots, we don't see that. And that would be 7, which means chlorine can only make 1 bond. Carbon can make 4 bonds. And nitrogen can make 3 bonds. And remember that you learned on the past that nitrogen is 3 minus, oxygen is 2 minus, and fluorine is 1 minus. That's where that comes from. Because for this to be totally full, which is what the elements want, I will have to put 1 more, and that will make it 1 minus. But we're going to talk about that later also. And then the last one we have is argon. Argon have 8 valence electrons, so 1, 2, 3, 4, 5, 6, 7, and 8. And as you can see, argon cannot make any bonds. And that matches with argon being a noble gas because they do not react with anything because they do not have any unpaired electrons to make bonds. So all the theory that we have learned so far matches with this model. So this is a very powerful model that allows you to work with all that on a very simplified way, but just by looking at those dots. Let's see what else we can do with the Lewis structures. So what about if you have ions like strontium 2 plus and sulfide 2 negative? So what are you gonna do? Well, let's do the Lewis structure for strontium. Strontium is gonna be here. So that means the noble gas prior to it will be krypton. So you're gonna have krypton. And 1, 2, 3, 4, 5, 5s2, which means strontium have 2 valence electrons. However, we're not dealing with strontium, we're dealing with the strontium 2 plus, which means that it's lacking 2 electrons, therefore positive, so that means that's gone and that's gone. So that's a Lewis structure without dots? Yes, because they're gone. So to represent that this is not just strontium, but strontium 2 plus, we put it on brackets and we put 2 plus on the outside. So the Lewis structure of an ion where the electrons do not show at all, you have to put the brackets with the charge on the outside. After you put the brackets with the charge on the outside for any ion, be positive or negative. So what about sulfur? Where sulfur is going to be right there, which means the closer noble gas going backward is neon. So neon, 3s2, 3p4. So that means that sulfur is going to have 6 valence electrons because this is the valence share, right? So 1, 2, 3, 4, 5, and 6. But we're not dealing with sulfur, right? We're dealing with sulfide. It's negative, so that means that it's gaining electrons. So we're gonna add 2 electrons, and I'm putting them hollow so you can see them. So how do I show that this is sulfide? I put a bracket and I put the charge on the outside. So that's how we can do that. Now let me go back to the first one, and I'm gonna show you an easier way of doing this. So an easier way would be by doing this. Let's do nitrogen. Nitrogen is on group 15, which means I have 5 valence electrons. So nitrogen, 1, 2, 3, 4, 5. So you can do this without the electron configuration. You just have to know that the group number gives you the valence electrons. Carbon. Carbon will be group number 14. So carbon will be 1, 2, 3, 4. And then chlorine, group 17. So 1, 2, 3, 4, 5, 6, 7. And argon, group 18, which is going to mean 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And that's an easier way. That's an easier way to do the Lewis structure just by looking at the valence electrons. So now you're ready to do this daily work. And once you do that, you can probably work on this one also. And on that one also. So you already have what you need to be able to task these concepts there. And with that, I would say that we now know how to write Lewis structures for the element just by knowing how many valence electrons you have, and you also know how to do it if you have ions by adding or taking away electrons, and if you have an ion, you have to put the brackets with the charge on the outside. So when we come back, we're gonna start doing Lewis structure, but not just for elements, we're gonna start doing them for compounds now, and we will begin with the ionic compounds, metals and not metals. And we're gonna see, remember when you learn how to do compounds by doing the crisscross and keeping track of the charges? Now we're gonna see that with the Lewis structure, we can determine the crisscross without having to do all that. So that's it for right now. So when we come back, that's what we are going to be doing. So see you soon.